Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about differentiation. Now the question I've chosen to go through is 2016 Paper 1 Question 6 Part B. In this question we're asked to differentiate y equals x sine 1 over x. Now the key to this question is you need to recognize that this is x multiplied by sine 1 over x, which means the only way to differentiate this is to use your product rule. So you should go straight to your differentiation page in your log tables, and the product rule is given as dy dx is equal to u by dv dx plus v by du dx. Once you've identified it's your product rule, first thing I do is write out the formula. Then I write out u du dx, v dv dx, work them all out in your rough work, and then we'll sub them in. Now in this case, my x is u, and my sine 1 over x is my v. So I've subbed in that u is equal to x, which means the u dx must be the derivative of x. The derivative of x is just 1. My v is sine 1 over x. Now before I differentiate this one, my life will be made a lot easier if I simplify v down first. And in order to do that, I'm going to use one of my rules of powers. So if you go to page 21 in your log tables, one of your rules of powers is that 1 over a to the power of p is equal to a to the power of minus p. So I have 1 over x to the power of 1. 1 over x to the power of 1 is the same as x to the power of minus 1, which means I can rewrite v as the sine of x to the power of minus 1. And that's just going to make my life a little bit easier when I differentiate. So now I want to get the derivative of sine x to the power of minus 1. Well, the derivative of sine x, if you look straight in your log tables, the derivative of sine of an angle is cos of that angle. So sine x to the power of minus 1 just becomes cos x to the power of minus 1. But now I need to multiply by the derivative of the algebra. So I need to multiply by the derivative of x to the power of minus 1. Well, the derivative of x to the minus 1, I bring the power in front, so it's minus 1 comes in front, and I decrease the power of x by 1. So instead of being to the power of minus 1, if I decrease that by 1, it becomes x to the power of minus 2. Now, if I have x to the power of minus 2, that's the same as 1 over x to the power of plus 2. So if I want to simplify this even further, I can rewrite this bit as minus 1 over x to the power of 2. And then I also have a cos x to the power of minus 1 on the top. So that's it simplified fully. And when you're doing your product rule, if you've written that out first, now to sub into my formula, it's very basic. So my final answer, my dy dx, is instead of u I can put in x. Instead of dv dx, I can put in minus cos x to the power of minus 1 divided by x squared. And then my second term will be v, which was, my v was sine 1 over x. So v is sine 1 over x, and du dx is just 1. So I suppose I can put in a 1 there. So now I can simplify this a little bit. So I have an x on the top here, and I have an x squared on the bottom here. So one of the x's on the top will cancel with one of the x's on the bottom, which means I'm just left with an x to the power of 1 on the bottom. So my first term, I could write this as minus the cos, and x to the power of minus 1 is 1 over x. I think it's just a bit neater when you're writing your answer to write it as 1 over x rather than x to the power of minus 1. And that's all divided by x. So that's my first term. My second term is just sine 1 over x. So my final answer, my dy dx, is minus cos 1 over x divided by x plus sine 1 over x. Okay, so now for the next part of this question, we're asked to find the slope of the tangent to the curve x sine 1 over x when x is 4 over pi. So I've drawn a rough sketch here. Let's imagine that this is my curve. Now it's probably not, I've just drawn a random curve. So let's imagine that this is my x sine 1 over x. And I'm asked to find the slope of the tangent to a curve at a certain point. Let's say this is the point where x is 4 over pi. A tangent is a line that touches a curve at one point only. Okay? I've been given no information about this tangent. So it would be impossible for me to find the slope of the tangent because I have no information about it. The only piece of information I have is that it touches the curve when x is 4 over pi. So when x is 4 over pi, or at this point, the slope of the tangent and the slope of the curve are the same thing. They have to have the same slope when they touch. So the question says find the slope of the tangent to the curve. But you need to recognize that the slope of the tangent and the slope of the curve is the same thing. So at the point where they touch, the slope is the same. So the question is actually find the slope of the curve when x is 4 over pi. So find the slope of the curve when x is 4 over pi. That's very straightforward based on what I've done from B part 1. Because in B part 1, I've already got the derivative of my curve is minus cos 1 over x divided by x plus sine 1 over x. Remember, when you differentiate, you're finding the slope. So this is the slope of the curve. So all I need to do in this question is find the slope of the curve when x is 4 over pi. Now the one thing you need to recognize is that this is in radians. 4 over pi, that's in radians. So you'll only get the correct answer if you have your calculator in radians. So all we need to do is sub in our x value and find the slope when x is 4 over pi. So let's work our way through that now. Okay, so you'll notice here that all I've done is everywhere there was an x, I subbed in 4 over pi. And my first term became minus 0.555, and my second one was 0.7071. So when I add those together, I get 0.1521. The question asked me to leave it to 2 decimal places, so my final answer is 0.15. So the slope of the curve, and by extension the slope of the tangent, when x is 4 over pi, is 0.15. Okay, so again, I hope this video made sense. If you're unclear on any of that, then just let me know in class or send me an email, and I'll try and explain it differently.